All right, so have you ever stopped to think about what software is actually running our entire global financial system? You might think it's some super modern, cutting edge language that was cooked up last year, but the answer is going to surprise you. It's a technology that's basically been around since the dawn of the computing age. So let's pull back the curtain and take a look at this incredible paradox. And this is the big question, right? How is it possible that a programming language from 1959, the same year Alaska and Hawaii became states, by the way, is still the bedrock for modern banking, insurance, and even government systems? I know it sounds impossible, but when you dig in, the reasons are actually surprisingly logical. So first things first, what even is COBOL? Well, the name kind of says it all. Common Business-Oriented Language. It was created for one specific purpose, to handle massive amounts of business data. And its killer feature? It was designed to be English-like, so that, a business manager, not just some hardcore programmer, could look at the code and get a general idea of what it was supposed to do. Now, if you're thinking, okay, but that was then, just get a load of this number. It's estimated that a whopping 95% of all ATM transactions still pass through a COBOL program. Think about that. Every single time you get cash, you're interacting with a system that's built on a foundation that's over 60 years old. Crazy, right?
Yep, it's the silent workhorse that just keeps on chugging. COBOL is the engine running on these giant mainframe computers, stuff like the IBM Z, and it's processing everything, from your bank balance and insurance claims to Social Security payments. It was built to do one thing and do it perfectly. Handle huge, huge volumes of critical data with absolute reliability.
So, to really get why it's so incredibly reliable, we need to look at how it's built. And I want you to think of a COBOL program less like modern code and more like a super detailed architectural blueprint. Every single part has a very specific designated place. You see, every single COBOL program, and I mean every single one, no exceptions, is built from these 4 mandatory parts, or divisions. Think of them as the 4 main chapters of that blueprint. If you can understand these, you're well on your way to understanding COBOL.
Okay, so it all kicks off with the identification division. This is just like the title block on a blueprint, It answers the most basic questions. What's this program's name? Who wrote it? When was it written? Every program has to introduce itself first. It's simple, it's clear, and you can't skip it.
Up next, you've got the environment division. This is where the program gets really specific about its surroundings. It basically has to declare, hey, this is the exact kind of computer I'm going to run on, and these are the exact files I'm going to need to talk to. In our blueprint analogy, this is like the section that lists all the approved tools and materials for the job. Now we get to the data division, and this one is a really big deal. Just imagine this. You have to list every single piece of information a program will ever use right up front. That's what COBOL makes you do. Every variable, its exact size, its data type, it all has to be defined before you can write a single line of actual logic. It's all about making sure there are absolutely no surprises later on. And only after all that planning, all that setup, do we finally get to the procedure division. This is the action part of our blueprint. This is where you find the step-by-step instructions, the actual logic that tells the computer what to do with all that data we so carefully defined earlier. And the structure here is just absolute. It's like a legal document. The main divisions are broken down into sections, which are then broken into paragraphs, and so on all the way down to the individual statements. You can't just stick a sentence wherever you feel like it. It has to live inside the correct paragraph, inside the correct section. This rigid hierarchy is totally intentional. It's designed to force clarity. Okay, so let's move on to the next layer of this structure. If the divisions are the blueprint, then the syntax, well, that's the brutally strict building code that every single line has to follow. And this is where COBOL gets really, really unique. And I'm not kidding, this isn't just a best practice or a suggestion, it is an ironclad rule. Where your code sits on a line matters. Put a command even one single space to the left or right of where it's supposed to be, and the entire program just won't work. It fails to compile. It sounds incredibly frustrating, right? But believe me, there's a really powerful reason for this. Just take a look at this. Every single line of code is literally sliced up into these 5 areas. The first few columns are for line numbers, column 7 is for things like comments, but the 2 you really have to pay attention to are area A and area B. So here's the crucial part. This creates an absolute separation of concerns. The what? The program's overall structure, like division headers and section headers, must start in area A. And the how, the actual logic, the statements and sentences, must start in area B. You literally cannot mix them up. The language forces you to be incredibly organized.
Okay, so we've seen the rigid blueprint and the super strict building code. Now let's tie it all together and get back to our original question and see the real payoff. Why does any of this matter? And here it is. This is the punchline. Everything that makes COBOL seem old-fashioned or clunky or difficult, the strict divisions, the column rules, defining all your data up front, it's not a flaw. It is precisely the thing that has allowed it to run our most critical systems for more than 60 years. It's its greatest feature. So let's connect the dots here. Because the structure is so rigid, the code is always clear. Because the column rules are absolute, there's no room for ambiguity. And because all the data is defined up front, entire categories of common bugs are just impossible. They can't happen. Each rule builds on the last, creating this chain reaction that results in one thing: extreme, rock-solid reliability. So I'll just leave you with this thought. We live in a world that is obsessed with speed, agility, and constant innovation. But COBOL, it kind of reminds us that there's another set of values. When you're talking about trillions of dollars and the foundational systems of our entire economy, maybe, just maybe, the most valuable feature isn't being new, but being stable.